Hello everyone. So good evening. Here we shall solve some more KCET previous year questions on the chapter oscillations. So if you have any doubts regarding any question, or if you are unable to understand this, the steps of any of the solutions, then please write us in the comments section. And if you feel that you have more difficulty in any of the chapters of physics, then also please mention the name of that particular chapter in the comments section, so that we can give more priority on it, and we will solve more and more questions on that chapter, which shall be helpful for your KCET exam. Also, the homeworks on every chapter will be uploaded in the Sapience Education application. So please install our Sapience Education application, whose link has been provided in the description. So here we shall start off with the very first question on the chapter of oscillations. So the first question is told that two simple harmonic motions are represented by y1 equal to 5 sine 2 pi t plus root 3 cos 2 pi t and y2 equal to 5 sine 2 pi t plus pi by 4. Now therefore this y1 that can be written as 5 into, so from here 2 I can take as common, so it will be 5 to the 10, and this we can write sine 2 pi t into half will be, we can write cos pi by 3 plus this is cos 2 pi t into this is sine pi by 3. So this is sine a cos b plus cos a sine b. So this is 10 into sine a plus b. So this is 2 pi t sine 2 pi t plus pi by 3. So y1 is this. So then the ratio of their amplitudes is, so therefore ratio of their amplitudes that will be equal to a1 by a2. So a1 is the amplitude of y1, which is 10, and a2 is the amplitude of y2, which is 5. So that is 2 by 1. So 2:1 is the answer. Option B is the correct answer. So then it is told a particle executing a simple harmonic motion has a period of t 6 seconds. So the time period of the simple harmonic motion is 6 seconds. The time taken by the particle to move from the mean position, so it will move from the mean position to half the amplitude. The time taken by the particle to move from the mean position to half the amplitude starting from the mean position. So let's say the amplitude is a, then this amplitude is a by 2. So what time it will take? So we know that the equation of motion will be x equal to a sine omega t. At t equal to 0, it is at 0, it is at the mean position, a sine omega t. So here omega is 2 pi by t, so that is equal to 2 pi by 6, that is pi by 3. So which is equal to a sine pi t by 3, pi by 3 into t. So therefore x will be equal to a by 2 at which time, that we have to find. At time t equal to how much? Okay, so therefore a by 2 that will be equal to a into sine 2 pi t by 3. So a and a will cancel. So then we can say sine pi t by 3, that is equal to half. So half is equal to sine pi by 6. Now therefore pi t by 3, that is equal to pi by 6. So therefore t will be equal to pi and pi will cancel, 3 to the 6. So t is equal to half second. So option B is the correct answer. So it will cover half of the amplitude in a time interval of 1/2 seconds. So if you are unable to understand any of the steps of the solution in any question or any other doubts if you are having, then please write us in the comments section. We shall clarify them in the subsequent videos. Here it is told that the circular motion of a particle with constant speed is the circular motion of a particle with a constant speed. So this v is constant, speed v is constant. So it is periodic but not SHM, SHM but not, okay. So it is a periodic motion but it is not SHM. So option A is the correct answer. So it is a circular motion. So why it is not SHM? The full form of SHM is simple harmonic motion. So it is not SHM. Since why? Since in SHM we should have to and fro motion. To and fro motion. It means that it should be oscillatory motion. Then only we can say it is SHM. But here there is no oscillation. But the same motion is happening after every complete circle. After every complete round, the motion is repeated. So therefore it is periodic. The circular motion is periodic, but it is not SHM. So then question number 4, it is told particle executes SHM with amplitude is 0.2 meter and the time period t is 24 seconds. The time required for it to move from the mean position to a point 0.1 meter from the mean position. That means half the amplitude at how much time it will cover. So now therefore the equation of motion of the SHM can be written as x equal to a sine omega t. Since why we can assume that at time t equal to 0 it was at the mean position. So omega is 2 pi by t, where t is the time period of the SHM. So that is 2 pi by 24, that is pi by 12 Hertz or pi by 12 second inverse. Okay. So this will, so a at, we have to find x is equal to a by 2 at which time? A by 2 is equal to a sine omega t. So therefore sine omega t, that is equal to half. Now omega is pi by 12, so I can say sine pi t by 12, that is equal to half, that is sine pi by 6. So therefore pi t by 12, that is equal to pi by 6. So pi will cancel, so t is equal to 12 by 6, that is 2 seconds. So it will, so the time required for the particle undergoing SHM to move from the mean position to the point 0.1 meter from the mean position, that will be equal to 2 seconds. So option A is the correct answer. Okay. Then here it is told a 10 kg metal block. A 10 kg metal block is attached to a spring of spring constant. So spring constant is 1000 Newton per meter and the block is having mass 10 kg. The block is displaced. So the block is displaced from the equilibrium position by 10 centimeter and then it is released by 10 centimeter and then released. So it means that the amplitude is 10 centimeter. Amplitude of the SHM will be 10 centimeter only. The maximum acceleration of the block is, so we know that acceleration is equal to minus omega square into x. So therefore the maximum acceleration will be equal to omega square into a, where a is the amplitude, since the maximum value of x will be equal to the amplitude only. So that will be equal to omega square. Omega is 2 pi by t So we know that omega is root over k by m. Omega is root over k by m. For a spring mass system, the angular frequency for a spring mass system, so it is obviously a spring mass system, the angular frequency of the SHM, that is the angular frequency omega of the SHM is given as root over k by m, where k is the spring constant and m is the mass of the block which is attached with the spring. So therefore here, so maximum acceleration, that will be obviously equal to omega square, that is equal to k by m into a. So k is 1000 divided by mass, that is 10, and amplitude we have to take it in SI unit in meters, that is 10 into 10 power minus 2 meter, that is 1 by 100. So this is 0.1 meter. So into 0.1, this much will be in meter per second square. So 0.1 into 1000, that is 100 by 10, that is 10 meter per second square. So option B is the correct answer. Then here it is told that the ratio of kinetic energy to the potential energy of a particle executing SHM at a distance equal to half its amplitude. So suppose there is a simple pendulum which is performing SHM. The bob of the simple pendulum is performing SHM, and suppose the amplitude is A. So we have been asked to find the ratio of kinetic energy to the potential energy, that we have to find the ratio of kinetic energy to the potential energy of the particle executing SHM at, so this ratio when we have to find at a distance equal to half its amplitude, means suppose here the amplitude is half of its amplitude. So at this point, at x equal to a by 2, half its amplitude, the distance being measured from its equilibrium position. So this one is the point O, this is the equilibrium position. So from the equilibrium position only, the distance x is being measured, that is half of the amplitude. And so at x equal to a by 2 only, we have to find the ratio of kinetic energy to the potential energy of this of this particle executing SHM. So let's say the mass of the bob is m. So we know that the so the kinetic energy is obviously half mv square, and the potential energy is or except or instead of taking this kind of system, also take we we can also take a spring mass system. So suppose if we take a spring mass system, then it will be somewhat like this. Now this is the mass. Suppose the amplitude is still here. This is the amplitude. So here at a by 2, x equal to a by 2. So here we need to find, now it means that this is the equilibrium position. Now here at this point x equal to a by 2, we need to find kinetic energy by the ratio of kinetic energy and the potential energy, and this is the equilibrium position. Now, so here we know that the equation of motion for the SHM, the equation of motion, therefore the equation of motion for the SHM, is given as x equal to a sine omega t, if initially it was in the equilibrium position, if we assume that if at t equal to 0 x was equal to 0 only, it means initially it was at equilibrium position. So a sin omega t. So then from here we can say v is equal to dx by dt, and the spring potential energy that is given as half kx square, and dx v equal to dx by dt, so that will be a omega cos omega t. So half mv square, that will be half m, and here omega square equal to k by m, omega square equal to k by m for spring mass system, where omega is the angular frequency of the SHM. So for spring mass system, the omega square is given as k by m, where k is the spring constant and m is the mass of the block which is performing SHM. So then so half mv square, we can say that is a square omega square cos square omega t, okay, and half kx square, that will be half k into x square, that is a square sine square omega t. And see, so from here we can say k is equal to m omega square, m into omega square, that is equal to k. So therefore the kinetic energy can also be written as half k a square into cos square omega t. Now when the distance is equal to half its amplitude, when x is equal to a by 2, then we can say that a by 2, that will be equal to a sine omega t. So then we can say that sine omega t, that should be equal to half. So sine omega t will be half when x equal to a by 2. So when x is equal to a by 2, when it is half the amplitude, when the distance is equal to half of its amplitude from the equilibrium position, so then we can say that sine omega t, that should be equal to half. So cos omega t will be how much? Cos omega t will be square root of 1 minus sine square omega t. That is equal to square root of 1 minus 1 by 4. That is equal to 3 by 4. That is root 3 by 2. Now therefore, the ratio of kinetic energy divided by the potential energy. The ratio of kinetic energy to the potential energy. So that is, kinetic energy is half k a square into cos square omega t divided by, this will be the spring potential energy, that is half k a square into sine square omega t. So half k square will cancel. So cos omega t, that is root 3 by 2 whole square, and this is sine omega t, that is half whole square. So that is 3 by 4 divided by 1 by 4. So that is equal to 3 by 1. So that is, the ratio is 3 is to 1. So therefore kinetic energy is to potential energy, that is equal to 3 is to 1 when x is equal to a by 2 from the equilibrium position, So therefore the answer is option C. Option C is the correct answer. So then in question number 7, it is told that a particle executing SHM has maximum speed of 0.5 meter per second. So let us assume it as a spring mass system. So the block is having mass m, and the spring is having spring constant k, and the particle executing SHM has a maximum speed v max, that is equal to 0.5 meter per second, and the maximum acceleration a max, that is 1 meter per second square. Then the angular frequency of the oscillation, means omega, that is being asked. So now we know that the equation of motion for the SHM, or we can say equation of motion of the particle executing SHM, is given as x equal to a sine omega t. If we assume that if at t equal to 0, initially it was at x equal to 0. So if we assume that initially it was in the equilibrium position. So therefore, the maximum value of x is obviously the amplitude, and we know that v is equal to dx by dt, so that will be equal to a omega cos omega t. So therefore, the maximum value of the maximum speed of the system, that will be equal to a omega, where a is the amplitude. And obviously acceleration is dv by dt, so that will be minus a omega square sine square omega t, sorry, sine omega t, so that will be minus omega square into x. So therefore the maximum value of the acceleration, that will be equal to omega square into a, omega square into the amplitude, which is equal to omega times v max, we can say. So therefore the maximum acceleration is given 1, which is equal to omega times v max, which is 0.5. Therefore the angular frequency of the system will be, so omega equal to 1 by 0.5, so which is 10 by 5, which is 2, so which is 2 radian per second. So 2 radian per second means option A is the correct answer. Then in question number 8, it has been told that two simple pendulums A and B are made to oscillate simultaneously, and it is found that A completes 10 oscillations in 20 seconds and B completes 8 oscillations in 10 seconds. Then the ratio of the lengths of A and B is. So there is one pendulum. This is pendulum A and this is the pendulum B. Okay. So now here, suppose the length of the pendulum A is A, length of the string, and length of the string in the pendulum B is suppose LB. So then therefore here it is told that the pendulum A completes 10 oscillations in 20 seconds. So therefore the time period of oscillation for the pendulum A, that will be equal to 20 by 10, which is 2 seconds. Since why, for 10 oscillations it will take 20 seconds, so for one oscillation it will take 2 seconds. And the time period of oscillation for the pendulum B, that is equal to 10 by 8 seconds. Since why, for 8 oscillations it take 10 seconds, so for one oscillation it will take 10 by 8 seconds, which is 2 4s are 8, 2 5s are 10, which is 5 by 4 seconds, which is approximately, which is equal to 1.25 seconds. So now therefore we know that for a simple pendulum, uh, the time period of the SHM, for a simple pendulum, the time period is given as that the time period of SHM is given as T is equal to 2 pi root under L by G, where L is the length of the string in the simple pendulum and G is the acceleration due to gravity. So therefore T is proportional to root under to T, the time period T is proportional to the square root of the length. So therefore we can say that the time period of the pendulum A by time period of pendulum B, that will be equal to root over LA by root over LB. So we have to find the ratio of the lengths of A and B. So therefore LA by LB, that will be equal to TA by TB whole square. Okay. Now therefore the ratio of the lengths of pendulum A and pendulum B, that will be equal to TA square by TB square. So means the time period of A whole square by time period of B whole square. So time period of A is 2, so this will be 2 square, and time period of B is 5 by 4, so 5 by 4 whole square. So this will be equal to 4 by 25 by 16. So this will be 16 4s are 24, 24 by 25. Okay, so this is the ratio of the lengths. Okay, 20 by 10 is 2, 8, 100 by G. Okay, root under L. So this is 4, 2 to the 4 by okay, sorry, this is 16, 25, 16 into 4. Okay, 4 by, so 4 into 16 by 25, so 16 4 is 64, so 64 by 25, so length of A by length of B, that is 64 by 25. So therefore the required ratio is 64 by 25. So option D is the correct answer. So then in question number 9, it is told that a piston is performing SHM in the vertical direction. There is a piston is there. Yeah, some gas is there. Some gas is being inserted in the tube, and one piston is there. Piston. The piston is performing SHM, means to and fro movement in the vertical direction with a frequency of the SHM is 0.5 Hz. A block of 10 kg is placed on the piston. Okay, so a block of 10 kg is placed on the piston. One block of 10 kg, its mass is 10 kg, and this is the piston. The maximum amplitude of the system such that the block remains in contact with the piston. So what should be the maximum amplitude of the piston? So we know that when the piston will accelerate downwards, then the normal reaction on the block, that will decrease. So if we draw the free body diagram of the block, if we draw the free body diagram of the block, then the normal reaction which the piston exerts on the block, that will be vertically upwards, and the weight, that is mg, which means the weight of the block, that will be downwards, and it is and the whole system, the block along with the piston is accelerating downwards with acceleration a. So now therefore, and the mass of the block is a m, suppose, so therefore we can say that mg minus n, that is equal to ma. So therefore the normal reaction will be m into g minus a. So now it is told the maximum amplitude of the system such that the block remains in contact with the piston. So therefore n should be greater than or equal to 0 for the block to remain in contact with the piston. For the block to remain, since why, if the normal reaction is equal to 0, then we can say that then the contact is lost. Then the contact is lost. So n should be greater than equal to 0 for the block to remain in contact with the piston. Contact with the piston. So now therefore m into g minus a, that should be greater than or equal to 0. So what should be the maximum amplitude of the system? So now we know that for any SHM, the equation of motion is given as, for an SHM, the equation of motion is given as x is equal to a sine omega t, where if we assume that if at t equal to 0 x was 0, it means at t equal to 0 the piston was in the equilibrium position. If at t equal to 0 the piston was in the equilibrium position, then we should assume that x equal to 0 at t equal to 0. It means that x equal to a sine omega t. So now the acceleration, we know acceleration equal to minus of omega square x, the acceleration. So therefore the maximum acceleration should be equal to omega square into the amplitude. So now here it means we should write that a should be less than or equal, m will cancel, so a should be less than or equal to g. So it means that the maximum acceleration should be also less than or equal to g. It means that omega square a, that should be less than or equal to g. It means that the maximum amplitude, that should be equal to a by, that will be equal to g by omega square. Maximum amplitude should be equal to g by omega square. So therefore the maximum amplitude of the piston, or the maximum amplitude of the system such that the block remains in contact with the piston, that should be equal to g by omega square. Should be equal to g by omega square. Now here it is told that the frequency is 0.5 hertz. So this is g by, so omega is 2 pi into the frequency. So this is 4 pi square into nu square. So this will be g is 10, and but g I can say that is 9.8 approx. So 4 into pi square is also approximately 9.8. Pi square we can say that is equal to, so pi square means approximately that is 3.14 into 3.14. So that will be, okay, 3.14 into 3.14. So it is approximately 9.8 only. So into nu square, nu is 0.5. 0.5. So this will be 0.5 whole square actually. So this is 9.8, 9.8 will cancel. So this is 1 by 4 into this is 1, 0.5 means half. So 1 by 2 whole square, that is 1 by 4. So this is 1, approximately 1 meter. 1 meter. So option B is the correct answer. Option B is the correct answer. So the maximum amplitude that the system can have, the block and the system of the piston and the block can have a maximum amplitude of 1 meter. Okay, then we shall solve the last question of our class on oscillations. So here it has been told that a tray of mass 12 kg, a tray is there. Now this is the tray is there, tray of mass, this is 12 kg, is supported by two identical springs, and this is the floor. So this is identical spring, means their spring constants are also same. When the tray is pressed down slightly and then released, it executes SHM in the vertical direction. So in the vertical direction, it will perform SHM. The tray is pressed down slightly and then released, it executes SHM with a time period. The time period of the SHM is 1.5 seconds. Then the spring constant of the of each spring is how much? Okay, that is being asked. So now when two springs are connected in parallel, so we know that when two springs are connected in parallel, then we can say that the net force, the net spring force equal to F1 plus F2. It means that and their extension will be the same. It means that K equivalent into X, that will be equal to K1X plus K2X. It means that K equivalent will be equal to K1 plus K2. It means that when two springs of spring constants K1 and K2 are connected in parallel, then their equivalent spring constant then the spring constant of the equivalent spring, it means that if those two springs can be replaced by a single spring, then its spring constant will be equal to K1 plus K2 if those spring constants are K1 and K2. Now here the two spring constants are same, so therefore here K equivalent will be equal to 2K. Since why? Since here K1 equal to K2, that is equal to K. So now therefore the time period of the SHM in a spring mass system, is given as T equal to 2 pi root under m by k. So that time period is given as 1.5 seconds. So the spring constant k we have to find. K. So now therefore it is given that T equal to 2 pi root under m by k, that is equal to 1.5. It is equal to 1.5, and mass is given as 12 kg, and time period that is given as 1.5, and k we have to find. So therefore this is 2 pi, so this is 3.14 into root over m 12 by k, that is equal to 3 by 2. Okay, so therefore root over 12 by k, that is equal to 3 by 4 pi, actually 3 by 4 pi. So therefore 12 by k, that will be equal to 9 by 16 pi square. 12 by k will be, so if we square on both sides, then this will be 12 by k, this will be 9 by 16 pi square. So therefore we can say that 9k, that will be equal to 12 into 16 pi square. Now therefore k will be equal to 12 into 16 pi square by 9. So 3 3s are 9, 3 4s are 12. So therefore k will be equal to 16 4s are 64, 64 pi square by 3. 64 pi square by 3. Therefore k is equal to 64 into pi square, means this is 1.4, 3.14. Okay, 3.14 into 3.14. So 3.14 into 3.14 if I do, so then this will be approximately 9.86 approx. So 9.86 divided by 3. So this is 3 3s are 9, then 3 2s are 6, 3 9s are 27, approximately 3.29. So this is, so k is approximately 64 into 3.3 approx. So 64 into 3.3 if I do, then this will be approximately 3 4s are 12, 3 6 are 18, 192, then 192, then this will be 2 11 9 10 11 2. So this is 211.2 approx. Okay, so this will be actually, so 64 PC93 for the 12, 64 into pi square divided by 3. So this is approximately k is so therefore k is approximately 211.2. Now therefore the closest answer, we have to choose that option which is closest to our answer. So that is coming 105 by root under, now m is 6 kg. Okay, sorry, here this will be k, but here we have to use 2k actually. There is something wrong here, sorry. To cancel this. Now therefore T will be equal to, here we have to use k equivalent instead of k. So T will be equal to 2 pi root under m by k equivalent, that is equal to 1.5. This is given. The time period is 1.5 seconds, that is given, and mass of the tray, that is given as 12 kg, and K equivalent we have found that is equal to 2K. So therefore T that is equal to 2 pi root under 12 by 2K, that is equal to 1.5, which is 3 by 2 we can say. So therefore 2 pi root under 6 by K, that is equal to 3 by 2. So therefore we can say that root over 6 by K, that is equal to 3 by 4 pi. So now we have to square both sides, then we will get 6 by K, that is equal to 9 by 16 pi square. So therefore 9K, that is equal to 16 6 96 pi square. Therefore K is equal to 96 pi square by 9. So this is 3 3 is a 9, 3 3 9, 3 2 is a 6. So this is 32 pi square by 3. So therefore K is approximate. So K is approximately 32 into, now pi square is approximately 9.86. 9.86 divided by 3. So this will be 3 3 is a 9, 3 3 2 is a 6, 3 8 is a 20, 3 9 is a 27. So it is approximately 3.3. So therefore K is approximately 32 into 3.3. So 32 into 3.3 is how much? So this is 3 to the 6, 3 3 are 9, then 96. This is 6, 15, 15, 9 plus 6 is 15, 9 plus 1 is 10. So 105.6. So therefore K is approximately 105.6 Newton per meter. So which is approximately 105 Newton per meter only. So option A is the correct answer. Option A is the correct answer. So here we shall end our class on oscillations. So hope you have understood all the steps of the solutions of these 10 questions which are based on the previous year KCET exam. So if you are unable to understand any of the steps of the solutions and any other doubts if you are having, then please write us in the comments section, and please install our Sapience education application where we shall upload the homework questions based on the previous year KCET exam, which shall be helpful for your KCET exam. So thank you everyone. Bye.